Okay, this second video follows on immediately from the first video on linkages that we looked at previously. So we're going to start off looking at cams and followers. Now, cams and followers simply change one type of motion into a different type of motion. So if you look at this mechanism here, as this cam rotates in a rotary motion, this device here, which is called a follower, moves up and down, and that is reciprocating motion. Now, this is used in a lot of different places. The most common one would be in a car engine, where you have the camshaft. As the camshaft rotates, the cams push open the valves, allowing fuel and air into your car engine. It's also used in a lot of printers and things like that. If you have a printer at home, various things move it up and down, so it's used in a lot of different places. Next, we have the crank and slider. This is another very common mechanism, for the simple reason being the crank and slider is the basis of every single car engine that are in the world. So our slider moves up and down, and it is moving up and down again in reciprocal motion. However, by using this connecting rod, which is a linkage, which is basically a lever, we can get a crank to rotate. Now, our slider in a car engine would be our piston. You have your connecting rod, and then our crank is our crankshaft. So this is how we get a car engine to convert the up and down motion of a piston into rotary motion of the crankshaft. Next, we have the ratchet and pawl. Now, ratchet and pawl is a very useful mechanism and has been in use for thousands of years. If you go on any historical trip to a castle, a ratchet and pawl is what was used to raise and lower the portcullis or raise and lower the drawbridge, in that when you're turning the crank, it will allow it to turn in one direction, but then the pawl cuts into the teeth, so that if you let go of the crank, it will not reverse, it will not go back in the opposite direction. So it's like a one-way system or a locking system, which prevents the load from dropping back down. It was used a lot in welds, it's used a lot in drawbridges, but we still use it even now. Springs. Springs are fairly self-explanatory. We can use springs in lots of different ways. They're used a lot in cars. We use springs to keep the valves closed in the engine. Springs are used as part of the shock absorbing system in a car engine. Even when you press your accelerator or press your brake pedal, springs are in use there to allow it to open. The brakes on your bike more than likely use springs to keep it open. Here you can see it being used on a piece of gymnastics equipment, the jump off, which is used for lots of gymnastics things. Cranks and a crankshaft. If you've ever used any of the pedal boats when you're on holidays or a child's car, then you will have used a crankshaft. Now, crankshaft acts like a lever, but it allows us to convert rotary motion into linear motion up and down. So in that respect, a crankshaft operates in quite a similar way to cam and follower. However, the big difference here is the crank and crankshaft converts up and down motion into rotary. The cam shaft and the follower converts rotary motion into up and down. It cannot convert up and down motion into rotary motion. So that's a big advantage of the crank and crankshaft over the cam and follower. Now, gears. This is an important one because virtually every single modern machine uses gears in some way. It's an extremely important part of many mechanisms, and the first one that most people become aware of is the gearbox in a car. Now, that's all you need to be able to know, is just identify that the gears are used there. Now, let's have a look at some common gears. So the first one is a simple gear train or simple gear system. This is where you simply have gears in a line, they mesh together, and this is the most basic type of gear system that you can get. These gears here are called spur gears. Now, typically, we use it to change the direction of rotation, and we use it to change the speed. That's the most common use of these types of gears. So let's have a little bit of a more in-depth look at these. So, in any gear system, you're going to have a driver and a driven gear. The driver is the one that's connected to your power supply. The driven is usually connected to your output. Now, the first thing to notice here is the driver and the driven are turning in opposite directions. That is very, very important, that two gears which are meshed together like this will always turn in opposite directions. That's a very, very important point to know. So, putting gears with different numbers of teeth together will result in a change of speed of the gear system. And it makes sense when you think about it. For example, if I look at this point just here, and let's say this gear has 20 teeth, this gear has 10 teeth. Now if I look at this point here, when gear A rotates once, 20 teeth will pass that point there. And because the two of these are meshed together perfectly, 20 teeth must also pass on the other side. Now, because gear B only has 10 teeth, every time gear A rotates once, gear B will rotate twice. And that's how we get our speed change in gears. Now, there is an equation to help you solve this. First of all, the basic rules of gears. The larger the gear is, the slower it turns. The smaller the gear is, the faster it turns. So if the big gear turns the small gear, you get a speed increase. If the small gear turns the big gear, you get a speed decrease. So here's our example. Gear A has 30 teeth. Gear B has 20 teeth. If gear A turns once, how many times would gear B turn? Well, gear A has 30 teeth. Gear B has 20 teeth. So that's 30 over 20, which is 1.5. So gear B, we've just found out, will turn 1.5 times, which means it is turning 1.5 times faster than gear A. Now, here is the calculation. To calculate the speed, and this is a very common question you get asked in exams, the motor gear here is 28, this has 10 teeth. You're told that this is turning at 100 RPM. What is the speed of this gear? Well, the speed of the driven gear, that's this here, is the number of teeth on the driver over the number of the teeth on the driven, and you multiply that by 100. So if the driver has 28 teeth and the driven has 10, it's 28 over 10 multiplied by 100 gives you a speed of 280 revs per minute. Now, we can't talk about gears without talking about an idler gear. An idler gear sits in the middle of two other gears. Now, there's a couple of things an idler gear does. The first one is it allows us to separate the driver and the driven a bit more. The second thing it does is it changes the rotation of the driven. Now remember, if you have two gears together, they turn in opposite directions. So if A is turning anti-clockwise, B is turning clockwise. If B is turning clockwise, C is turning anti-clockwise. So A and C are both turning in the same direction. Now there's a simple rule of turn. If you have an even number of gears, they are turning in different directions. If you have an odd number of gears, they are turning in the same direction. And that's a simple rule of thumb, but I have found it works every single time. The last thing is the idler gear makes no change to the driver-driven ratio. Here, if that has 20 teeth, and that has 20 teeth, and B only has 10 teeth, A and C will always turn at the same speed if they are the same size. So the idler gear makes no impact on the gear ratio between the driver and the driven. So basically, for any equation, you can ignore the number of teeth on the idler gear, just look at the driver and the driven. You have a worm and worm wheel. Similar to another gear wheel, a worm and worm wheel does two things. First of all, it changes the direction of rotation through 90 degrees. So if you were to look down at the top here, if there's your worm wheel, there is your output. So they are at 90 degrees to each other. A worm wheel is a screw, but all a screw is, it is a gear with one continuous tooth wrapped the whole way around it. We use this a lot in drive systems and things like that. It has a large number of advantages. First of all, it gives a large speed reduction. However, you also get a large power increase. It cannot slip. The gear wheel, the spur gear, cannot turn the worm gear. And lastly, it's very small in size. These motors can be extremely compact. Bevel gears, like these ones here, perform one basic job, and that is to change the angle of rotation through 90 degrees. If you look at your bevel gears like this, drawing's a little bit crooked. The angle of rotation is changed through 90 degrees. Now, where you see these a lot is you see them in old flour mills and things like that with the water wheels. But here they are, an old style drill or an old hand whisk. They use bevel gears to change that direction of rotation. We have our rack and pinion. Now, we've mentioned this before. It changes rotary motion in the pinion, into linear or reciprocating motion in the rack. They're used on train systems in the Alps, for example, when a train has to go up a very steep slope. They can also be used in things like roller coasters and things like that. But in the engineering room, a very common place you find this is in the drill. This is what makes the spindle on the drill go up and down. It is also used a lot in steering systems in cars. When you turn your steering wheel, it turns a pinion, which pushes the rack left and right, which causes the wheels to turn. And that's a very common and useful mechanism if you're making a car type project. Or chain and sprocket. This is something that you should be very familiar with from your bike. All a sprocket is, it's a toothed wheel that a chain slots into the teeth. It has a number of big advantages, and the biggest advantage is it won't slip. So like a gear, it won't slip. The other big advantage is you're only limited by the length of the chain. So the two sprockets, the driver and the driven, can be very far apart, linked together by the long chain. Now, you should be able to identify all of these different types of mechanisms. So it is important that you learn all of those different types of mechanisms. And that's our second video on mechanisms.